all be on page 28, and I believe it's recording. Great. We've talked about adding expressions. When you add expressions, it's one set of parentheses plus the other set of parentheses, right, with terms plus terms. Subtracting expressions, we had pretty much like a 2-term minus sign and then another like 2-term, or maybe it could have been a 3-term. For multiplying, we had maybe a 2-term times a 1-term, or 2 terms times 2 terms and stuff like that. So we got to make sure we know how to do this. We took a quiz, a group quiz on adding, subtracting, and multiplying expressions. Today what we're going to do is practice one more example of multiplying just as a little warm-up, and then we're going to focus on factoring. Okay, we're going to find the base and the height. Instead of finding the area inside the area model, we're going to find the dimensions, the length and the width. Remember, we're trying to put tile on our bathroom floor. We either know the length and the width so we can cover it up, or sometimes they give us the entire amount of tile and we got to find out the length and the width. So anyways, that's the lesson for today. I do want to give you a 10-minute break, so let's just go ahead and work on a few warm-up problems. So on page 28, if you can go ahead and turn your page there. For number 1, since we don't have addition or subtraction in between the 2 parentheses, we assume it's multiplication. So make 1 your base and 1 your height. So let's call this one my base, this one my height. Doesn't matter where you put them. 4 of the x tiles and 1 of the 1s. The height is 2 of the x tiles and 3 1s, positive 3 1s. Can we do the multiplication here, base times height? Yeah, can someone raise their hand and tell me what the top left corner is? I like the number 8, but x times x is x squared. Now, top right corner, 4x times 3.
12x.
Yeah, is it positive or negative? Positive 12x, good. Now, what is 2x times 1? Positive 1. Positive 2x. And then do base times height. 1 times 3 is equal to? 3. And it's a positive 3. So what can we do now? Everything's organized. It's an organized manner. Can we tell something, or what can we say about the diagonal terms? What can we say about the diagonal terms? Yeah, they're like terms. 12x and 2 more x's, that makes 14, right? So you can put them together. We know that 4x plus 1 then times 2x plus 3, that equals this guy, everything in here, which is 8x squared plus 12x plus 2x makes 14x plus 3. And box in your answer. Are there any questions on how to multiply 2 terms times 2 terms? In other words, a binomial times a binomial. Make sense? Okay, so I want you to give number 2 and number 3 a try by yourself. 2 and 3. So, yes, I do. So for number 2, we got 6x plus 3 times 2x minus 8. I hope you were able to make 1 your base and 1 your height. The x tiles and the 1s, and then your 2x tiles and your negative 8. Let's go ahead and go with group number 1. So, wait, it's your birthday today. Happy birthday.
Happy birthday, dog.
Okay, so let's go with James. What's the top left corner?
12x squared.
Good job. And then top right?
Negative 48x.
Good. And then bottom left?
6x.
Bottom right?
Negative 24.
Good. Now, can you tell me, Caesar, what your simplified expression is at the very end?
12x squared minus 42x minus 24.
12x squared minus 42x minus 24 is correct. So make sure that you combine these 2 terms. Some of you just write the whole amount of terms on there. Just make sure that whenever you're talking about the same tile, x tile, you combine them. Okay, let's go on to number 3 now. I think this one was a little bit more on the spicy side, but I think a lot of you are able to do it, right? This is the x tiles, the 1s, and then the x squareds, the x's, and the 1s. Okay, cool. So we filled it out. On the exam, I'm not going to make the table for you. So make sure you know how to do that. I'm not.
Why?
Because you should know how to do it by yourself.
Is it a
With
group
practice. It's going to be no, you only had one group quiz, the next is independent. So can someone tell me, let's call on group number 2. Can you tell me the entire top row? Someone from that group.
I don't know.
Okay.
2x cubed,
Uh-huh.
3x squared, and 5x.
Yes, very good job. And I told you guys that there's another way to do it. You know that x needs to be, it's the same height for all of those terms. So another way to do it is just by, some of you might not want to draw the table. You can just draw arrows and just in your brain tell yourself multiply. And then you also have another part of that, right? A part of that, the ones that needs to get, the 7 ones need to get distributed to all of those guys. They all have the same little height. Okay, just kind of wanted to show you a different way to do it. Sometimes arrows work better than boxes. So now let's go with this group right here, this group of 4. Can you tell me what the bottom row is equal to?
14x to the second power, and then 21x, and then 35.
Good. Okay, so this is the part where I had students in the past just write everything down, and I'm going to show you what they did. They did something like this, which is going to give them, like, I don't take off too many points. I only take off 1 point, right? Because they're technically not, they're not wrong, but I specifically said simplified expression. So I would like for them to combine the terms or the tiles that are the same, right? So here, oh, let me go ahead and 5x, like this guy would be good with this guy, and then this guy with this guy. I personally always look at the table, at my area model, at my box, and I look at the diagonals and I just add them in my head. So this is actually equal to 2x cubed plus 17x squared plus 26x plus 35. That is what you get when you multiply those 2 terms times the 3 terms. I would take off just 1 point. 4, so you would get a 4 out of 5.
So that's like a whole question.
That's one question right there. Okay, good. So let's go ahead now. Now that we reviewed multiplying, right? We took a test or quiz on all this, right? Group quiz. Hopefully that was really helpful. Yeah, I mean, just, to kind of understand a little bit more of what's happening. Turn to page 23 now. Where's 23? Here. And if you go to the one before 23, just to get a little reminder of what we did last time, do you guys remember, go to page 23. But do you guys remember this, what we did last time?
The taco.
Yeah.
The burgers, the nuggets, and the taco. And what did they all have in common?
The apples.
The apples, right? And we could order the apples separately, right? So since we could order the apples separately, we had to order what was left over here. We had to order the burger, the nuggets, and the taco. So that's one way to think about what we're going to talk about. We've talked about it already, factors. They give you the area. You got to find what's outside, right? The dimensions. So why don't we go ahead and talk about this? What is that? What is that called? These guys. I called it, it starts with the letter T.
Tree.
A tree. And the reason why we do a tree is because we need to find out what 2 things have in common, right? This guy and that guy, right? So we have to figure out the prime factorizations, and it makes life easier. So with that being said, can we go ahead and, you don't have to turn to this page, it's just for me to show you. But do you guys remember doing this problem? Where I had you guys do a tree for the first term, a tree for the second term, and a tree for the third. And I asked you guys to circle what they have in common. They had a 5 and 2, a 5, just a 5 in common. So that was your height for all of them, 5. And then your base, all you had to do was see what you had left over, right? All you had left over was that, and that's what would go here, right? So that is what factoring, finding the factors, the length and the width is called. Any questions on what we're going to do? We're going to do this, and we're going to do another example. So go ahead and turn to, so you guys are on page 23. Let's practice number 7 together. So for number 7, it's 3x plus 3. So if I were to put parentheses here, I can tell right away, I'm not adding that expression to another one. No, we're not adding. Are we subtracting? No. Are we multiplying? I mean, there's a 1 out here, but 1 times anything is itself. So we're not multiplying, so therefore we're finding the factors. So what I tell students is now we're actually working, instead of the dimensions, the length and the width of the room, we're looking at the entire area. So why don't we cover it by putting a box around it, right? I mean, I think that is helpful. Some of you might not benefit from a box. It's okay if you don't like boxes. But I like to put, this is my floor now. I need to find my length and my width. Some students like to even put a little, draw a vertical line that splits the 3x and the positive 3 term. That helps out.
Find the greatest common.
Yeah. And then we need to find out the length and the width here, right? So the only way to do that is if we find those missing values. Some people guess all the time, but don't guess. If you guess, you're gonna get it wrong 50% of the time, or 45% of the time maybe. But do your tree for each term. This is 1 times 3, and this is times x. This is equal to 1 times 3. Your goal is to get the greatest number in common. Okay? So what's the greatest number or variable that's in common to both?
3.
So that is the common height. Okay, good. That's what you pulled out of both of. They have the same, or at least let me show you. They both have a height of 3. Does that make sense?
Yeah.
So what is the base then? 3 times what will give you 3x?
1x.
1x or just x. Very good job. And I know I don't have space, so I'm sorry for putting the x, but you guys can circle that. Those guys are the remaining factors. What's going to be the other piece of that base? Just 1.
Well, 1.
Positive 1, right? Because 3 times positive 1 gives you a positive 3. So therefore, we know that 3x plus 3, the area, or here, let me write this down better. 3x plus 3, the area, is equal to base times this height. Isn't that cool? You just worked backwards. And you could check your work if you know how to multiply.
Okay, so the equation on the right would be the answer.
Correct. The dimensions, the base and the height. Remember, we're construction workers, right? Or if we're not construction workers, we're the overseers, and we got to make sure that they're doing their job. We got to make sure that, hey, this is the amount of tile you're given. What are the dimensions? And you can find it by finding a GCF.
Might be a marine biologist.
The marine biologists are going to be looking at a lot of rectangular tanks. Maybe finding the volume of the rectangular tank and see how many little tiny fish fit inside of it. Can we work on number 8 together? Can I show you a way? Like some of you might be like, I don't need to draw these boxes. I don't like drawing boxes. So then maybe this will benefit you. Shh. You can just start here. Yeah? I mean, I'm not forcing you to use a box, but it's a good understanding of what's happening. Shh. There is no adding expressions to it. There's no multiplying. There's nothing. So this is your area. So what 2 numbers multiply to 2? That's easy. And there's a total of 3 x's multiplied together. And remember, the 2 is important because 2 is the one that you would like for all the others to have a factor of, right? So we could definitely do 2 times some number equals 16. 2 times 8, and then you have 2 x's. Over here, the goal is to also get a 2, which we can. 2 times what makes 6? 3, and then bring down your x. Okay, awesome. So now that we looked at we did the prime factorization of each of those terms. Can someone tell me what they have in common?
2x.
Ooh, very good catch. It's actually 2x. Good. So that is our, and if you're doing your box, maybe this will help, right? This can, 2x is going to be your common height, right? So our answer is going to be 2x, parenthesis. And then what's left over, or not left over, but what are the remaining factors?
8.
2 times what will give you 2x cubed?
X squared.
X squared.
X squared. 2x times what will give you 16x squared?
2.
8.
Yeah, definitely an 8, right? Because 2 times 8 is 16, but what else?
X.
X. And you could just circle what is left over, right? Like, that's pretty much what's going to be there, and it's a positive 8x. Now, what about 2x times what will give you negative 6x?
-3.
Minus 3. Very good job. Oh, I forgot to put a little negative there, right? Because it's 2 times negative 3, so very good catch. Good, so that's what's going to go in here. This is the common base. Isn't that cool? I think it's pretty rad. And so that's what this guy is equal to in base times height form. Some of you, yeah, there you go. I'm going to press pause to the video. Go ahead and do number 9 and 10 by yourself.
Recording?
Mm-hmm. Oh, sorry. There you go. So that is what you get when you do your factor tree. Now, what do they both have in common?
2x.
The 2 and the x. Good job. So if you're using your box method, right, you know that this is the same height of 2x, which is very awesome. But now we need to find our factors for the base. So can someone tell me what my factors for the base are? Anybody? 2x times what will give you 18? 9x, good.
Minus 4.
And then we have plus 4. So therefore, 18x squared plus 8x can be factored into base times height, which is 2x times 9x plus 4. And that's it. That's your answer. You just need to make sure you take out the greatest common factor. All right, let's move on to number 10. And I think, Caesar, did you find the greatest common factor here? You didn't? Okay, at least I know that I can get the prime factorization of all this. Did you guys get the prime factorization of that?
Yeah.
Okay, what do they all have in common?
X. 1.
Just one of the x's, right? So why don't you take that out? Oops, sorry, I drew my rectangle a little bit. Yeah. So I can take it out, and that's what they have the same height. And I pretty much put the measurement in red, right? They all have the same measurement x. But what is remaining? What is the base, the factors of the base? There's 3 terms, obviously, right? 1 here, 1 here, 1 here. X times what will give you 2x to the 4th? What is it?
2x.
2x to the 3rd.
2x to the 3rd, and you could kind of circle all this, right? And then what about the middle term?
5x.
Plus 5x, it's a positive, right? And then x times what will give you x?
X 1.
1, positive 1, right? So that's when you want to get back to where you started. So let's say you already have what you want. You just know that 1 times anything is itself. So just put a little 1 there. So the answer here is x, oh, sorry, let me write down the area, 2x to the 4th plus 5x squared plus x. This equals x times 2x to the power of 3 plus 5x plus 1. So this is what you call factoring, and it usually happens when you have a GCF for all the terms, right? We see a GCF in all the terms. I see, you can do a tree for all of them.
Yeah.
But don't be confused, because 3 terms and 2 terms, just like the one we did, example 7 and 8, right? There's 2 terms on 7, and there's, right, number 7 has 2 terms, and number 8 has 3 terms. What would happen if we had 4 terms? Anybody know?
It's the same thing.
Pretty much the same thing, but we're gonna group. Kind of like if I say get into groups of 4, most of you would say, hey, let me pick my partner first, and then the other person can pick another partner or whatever. So usually when you get into groups of 4, you get into groups of 2 first.
Yeah.
That's usually what we're gonna do, okay? And we call this factoring by grouping, because first you're gonna group 2 to see what they have in common, and then the other two what the other 2 have in common. So with that being said, can you take out your handout?
Oh yeah.
The handout that I had you pick up. All right, so the essential question is, given the following area, x cubed plus 7, x squared plus 2x plus 14, whoa, that was a mouthful. You guys notice how there are 4 terms now, right? So we're going to start off by first inspecting the first 2. Is there a GCF with the first 2?
Yo, I got an answer.
Is there a GCF for the other 2? Shh, hold on. Yeah. So that's when you know you are going to group these in such a way where you put the 2 terms at the top and then the other 2 terms on the bottom. So organize it in such a way where it's like a Punnett square,
Yeah.
like a 2 by 2. Okay, like in bio. So here's what I'm going to do. I am going to strategically put the first 2 terms on top, right? I'm going to group them, x cubed and the 7x squared on top. And the bottom is going to be the 2x and the 14. I personally did not put the little plus sign, but if it helps you, you can put the little plus sign right there because it's a positive 14, it's a positive 7x squared. Your goal is to find the greatest common factor for the first 2 terms, right? What's in blue. How do you find the GCF of the first 2 terms? Everything we've been learning this far. Just go ahead and use your tree. So this is 1 times 7 times x, just like that. Right? What is the GCF here?
All of that.
X and 7.
They don't both have a 7. They both have x squared. Good job. So that is the GCF of the first row. Top of the house, if you want to think about it that way. Now, can you tell me what my base is? So technically what I'm doing is just focusing on this part. The second part of the height will come later, okay? So can someone tell me what my first part of the base is? X squared times what will give you x cubed? X. And now x squared times what will give me 7x squared?
That would be
7.
Positive 7. Very good job. Now, it has to be a positive. Yeah, I like that. I like for you to be specific. Can anyone tell me what this little guy has to equal then?
That's gotta be
2.
Plus 2.
It has to be positive 2. Very good job. And the reason why it's positive 2 is because 2 times x gives me 2x. And then 2 times positive 7 gives me a positive area of 14. So what we just did was find out what was common in both rows of factored areas. So what was in common was the x squared and plus, I think it just wants you to fill out x squared in both rows. Oh, I guess we can do that. That's what was in common with both, right? So we write that down, x squared plus 2. Oh, here, hold on. So we can say they both have the same height, so x squared plus 2. And the other, oh, sorry, my bad. I think I'm doing this wrong. Oh yeah, right here, x squared plus 2. And then the other one is x plus 7. There you go. I just want you to write them out. Base times height. This is your height, and this is your base. Any questions? Okay, so they both had the same height. Cool. Can we work on example 1A? And recall, on the exam, I'm not gonna put them all in a box for you. You have to do that yourself. I'm going to show you a shortcut to do this, or not a shortcut, but just like some of you don't like the box method. So I will go ahead and show you the little second method, the little trick to doing it without a table. So what we have here is a nice organized area model, and we got to find the GCF of the top row. It doesn't matter if you start with the bottom or the top, same thing, tomato, tomato. So what I'm going to do is I am going to do my prime factorization. Two numbers that multiply to 5 are 1 times 5 times x times x times x. I'm expanding x cubed. And then my goal is to get a number in common and maybe even a variable in common. Since this guy has a 5, right? You're like, 5? I know negative 10 could be made up of 5, right? If I do 5 times what? Negative 2. 5 times negative 2 is negative 10, is what I'm trying to say. You can definitely make a branch with the 5 in there. Yes?
Do you not do 1 times 10?
Well, if you do 1 times 10, then you wouldn't have a common factor at all.
Oh, because 5 is...
Yeah, so if you see a 5 and the 5 goes into the rest of the terms, then that means that's your common factor. So I know some of you are just thinking, well, it's a 10. 1 times 10 is a possibility. But break your tree down even more. But I don't like showing all of that because it would take up most of my page. So I just go straight to thinking, it's a 5. My other term has to have a 5. Okay. And this is expand x squared is just x times x. And they both have a 5 in common. And they both have how many x's? 2. I know a lot of you would like to do this in your head, which is awesome. Just make sure you always grab the x to the smallest exponent. Every single term, I promise you, if everything has an x, and every term has a specific exponent, just go with the smallest one. The smallest one's always going to be in the bigger one, okay? So anyways, so this is 5x squared, which a lot of you were able to get. Now, can I get a volunteer to tell me what the base will be? What will the base be? Yes, Jay. Correct. So the first one's x, 5x squared times x is 5x cubed, and then 5x squared times negative 2 is 5x squared times a negative 2 is a negative 10x squared. Good job. Another way to check your work, you'll never get it wrong by doing the tree. You can simply circle whatever's left. You could put a 1x there, but it's just x. And then what I circled in blue, those are your the rest of the factors. Questions? Concerns? Okay, let's see who can answer the second part. What's the second part of the height?
3.
How'd you get 3?
Because the x is only on the positive.
Yeah, it's a positive 3, right? Just like in bio, 3 times x is 3x, 3 times negative 2 is a negative 6. Very good job. So therefore, I had a student ask me a question. Well, what are the factors? The factors are, you did the hard part. Now you just have to put it all in one. It's base times height, which is equal to, it doesn't matter which one you put first, but if you would like to start off with 5x squared plus 3, like with the height first, that's okay. But this is your final answer. Are there any questions with this problem? Okay, so what I would like for you to do next is do part B, okay? Take this time to do part B. Thank you.
Ew.
Mm-hmm.
How do you cancel out like if it's, are we doing the graph figure?
Not yet, not yet. But good question. Okay, shh. So if we look at the top row, raise your hand if you know what the GCF is of the top row, Ireland. The GCF of the top row.
I know. I got these ones, but I didn't get that one.
Okay, so you need to make sure you get this guy. What'd you get here?
X squared.
X squared. Good job. So now we need to ask yourself, x squared times what will give me x cubed? Just one x. Good, because x squared times x, that's x cubed. Now x squared times what will give you x squared?
1.
X1.
A positive 1. Now tell me what the height, the remaining, it'll be 5. Very good job. Shh. Positive 5. So we're going to write this down as x squared plus 5 times x plus 1.
Break time.
All right, so we're going to have a 8-minute break. Well, 8 because you guys were talking too much.